Hi, it's Gadget UK here again, back for part 2 of Ravi's A4000 board repair. Ravi, as I mentioned in the previous video, is a co-host of the Retro Hour, so yeah, link down below to that. If you're not familiar, it's worth checking it out. They interview lots of interesting people. It's a really good podcast. You can get it on iTunes and stuff as well, I think, actually. Anyway, in the previous video, we swapped out the 245s in relation to the IDE. You know, the IDE was the initial fault that was reported. There were other things we covered in part 1 as well, including the 12-volt rail had burned up, and we had a RAM fault, but those were all sorted in the previous part. But we left it with the IDE, and we were waiting for a gal, I think. So the two gals are here. 901 is the one we were not particularly interested in. 902 was. And if you have a look at this, you can see these two pins here, IO-R and IO-W. That one's IO-read and that one's IO-write. So the pin that was short to ground was pin 18 there, IO-write. Well, we think it was. We need to remove it and see if the short goes away, I guess. So that's where we're up to in terms of the IDE faults. The buffers obviously were, obviously the first thing you would consider swapping here, because that's the most common type of failure. And I forget which one it was, but one of them had a stuck high data bit on. So yeah, it was two issues with this IDE. So the socket hasn't arrived yet, and I suspect it could be another 2 or 3 weeks because it's coming from China. Now, I've been rethinking this. I don't think there's any point in waiting for a socket. If we were unsure that this was the fault here, it's a different, it's a different situation, isn't it? If you're not sure, then yeah, it's a good idea to socket it. But we know that the pin up here that goes to the read pin, I think it's, is it the right pin on there, is shorted. Well, I'll check that on the meter in a minute before we remove it, but nevertheless we know there's a short there. It doesn't go anywhere else on the board, it can't be shorted anywhere else, it's got to be internal to that chip. And that will be causing the problem. We know that we had a fault on one of the 245s down here, but it seems that whatever's happened has killed two things at once here. So I spoke to Ravi and said, do you want to wait for a socket? And he said, well, I'll leave it up to you, leave it up to you, whatever you think's best. What I do know is they're easy to get off these, with hot air, so if it ever failed again, I could just then fit a socket. But I don't see a scenario where that might happen, unless he's got a faulty hard disk that he keeps plugging in that keeps destroying it. But if he does that, it's probably going to, because it destroyed one of these, didn't it, the 245s, it's going to destroy the 245 anyway, so it would need to come back to me no matter what. So I think, and I've got lots of these, well, several of these gals spare now, so I figure we'll just solder it straight on. So we'll get some Captain tape on those IDC connectors. I just want a little bit here, just to, I'll try and get it at an angle, just to protect that there. We'll get another piece down as well, just to double it up, like that. That will do. So that isn't going to melt, is it? And we're only here, so we don't need to worry about the, Zorro connector there. But if we just test on connectivity here, and I test from ground, you can't see I've got one probe on ground, and we test, we've got a short there, yeah, so it's that corner pin, and it shouldn't be. So let's get the hot air onto it and remove it. Yeah, there we go, we're just protecting the print on that. It might go weird, I don't know. There we go, it's starting to come up. Famous last words, it was moving then. There we go, just get that off. So yeah, I don't think the label survived, but it's off. So let's let that cool down a little bit, we'll clean up with a little bit of braid and we'll get the new chip on. We'll also just see if that short's gone actually, we can do that now. Let's put the meter on continuity. And if I just test from the ground again. Yeah, there we go, our short's gone. So it definitely was the IC. So we've got our GAL 16 V8D there. We need to get it into the PLC C2 DIP adapter. It should be nice and easy to get this in, and a bit fiddly though. Yeah, there we go. Press it down. So that's in there. There's an indicator on here that shows, you know, up towards the top, and that's exactly what you do. Pin 1 towards the top there, and close it. Connect up to the PC. So I'm using the Mini Pro TL866 here. We've loaded the software. We've got the GAL selected. In fact, that's a different one. That was when I was trying a different one earlier. So if we select Lattice, GAL 16V8B, and this is where things get a bit fuzzy because there's different sub-versions. You can get like a V8D, a V8C, a V8A. I'm not familiar with exactly what the differences are, but anyway, that's the one I've gone with, and that seems to work, I think. And if we do File Open, and then if we open the file, there's two here. There's one for a PAL, which was the original chip, and one for the GAL. So the .jet file there just defines the fuse map here in ones and zeros. And as I mentioned before, these kind of configure the logic within a GAL. You know, you've got lots of probably ANDs or ORs or something in there, and other types of gates, and you can switch them off and on and connect their inputs, you know, in and out of each other internally and to the I/O pins to create your own little custom logic. So that's what that fuse map is. We're going to set the encrypt flag down here off, and then we'll do device. Let's do blank check first. Verify. Yeah, it says here check memory empty, check memory empty successful, and then we'll do device program. And the key here is to make sure lockbit is not ticked, because we want to be able to rewrite that if it's not right, I guess. And just hit program. It will erase it to start with, and then it will program it. It says there, programming successful. If you've got the encrypt thing ticked there, you won't be able to read it back, so your verify will fail. And if you've got the lock bit set, you won't be able to rewrite the chip. So we need to remove the GAL from the programmer socket thing here, the adapter, PLCC to DIP. Oop, flew out there. So pin 1 is up here, there's a little dot there. Pin 1 on the board is marked with a giant 1. I just need to get this into position here and anchor a couple of points. So that's totally square and aligned. This is the hard bit now. I need to try and just anchor 2 points. So I'm going to barely try and even touch the thing. Add lots of solder, use the solder to do the work here. You see that? So I think that's held. And you can't really see very well what I'm doing here. I'm just coming around the other side. I'm going to do the same thing on the corner point down there. I think that's it. And then we'll just touch it just gently here. Yeah, that's in position. So as you saw when I programmed this, I didn't set the encryption bits or the lock bits. Now I think that just means that you could read it, you could dump it back again if you wanted to, or verify it, and you could also write it again if it became, if it lost its settings. I don't see any point in setting the lock bit, because it's a one-time thing then, isn't it? This is the other thing. If we had a socket on here, if I wasn't too sure what I was doing, a socket would assist with that process, wouldn't it, of testing it until we get it working just right. Now I think here I'm going to have to swap to the other iron, because it doesn't produce enough thermal, what's the word? It's not big enough, this tip, so it won't pass the heat very well. So I'm trying to do this through the LCD viewfinder. You can see it just heats a pin at a time with a bit of solder. Let's just add a little bit more solder there. May bridge a few pins here. Let's just see how we get on. If you heat the pin and the pad, it should just sort of trail down and join. I'm not sure if that has joined or not. Can't really see very well. And as I say, we may bridge a few pins here. This one's easy to do because it's kind of in the middle of the board. It's exposed. We've got a bridge pin there. Look, got 2 bridge definitely. You can see the bit of solder. Sometimes, obviously, drag soldering is your friend here, but not always with these. Yeah, we've got a big blob there, look. Let's just try and remove that with a little bit of braid. Yeah, almost got it away with the braid. Not quite. Oh, there we go. Hang on. Back again. Still looks to be a bridge there to me. Yeah, anyway, this is very hard for me to do and share. It's easier just to do it. There we go. Hang on. Yeah, anyway, I think you can see that's not too bad. I think they're all joined up there. So I just need to work my way around and do the same thing on all four sides. So that was quite painful to do, if I'm honest. It's not took very long. It was just a bit annoying because on a few pins there, on this side here, I bridged a few, so I had to use some braid. I would say that it's probably easier to fit a blooming socket, actually. If you do cut the base out, it's probably easier to fit a socket there than it is to solder these, are they J-leg or something? J something, I can't remember what they're called now. It's the way the pin goes underneath the chip there. It can sometimes be difficult to get the solder to flow so that it goes up the pin and on the pad. Yeah, there's still a lot of flux around there, but I can at least inspect it now and then we'll go test it. So I'll test it without the IDE first of all. Just make sure, oh, hang on, yellow screen, that's not good. So things have taken an unexpected twist here. It doesn't work. It's coming up with the yellow screen, as you saw. I was quite surprised to see that. I inspected around here, reflowed everything again. Just the same. There's no shorts or anything there. The solder points are good. So either this gal is not up to spec, it's not held the settings for one reason or other. Maybe I needed that lock bit set or something like that. I don't know. Or the encryption bit set. I don't think so. I think one of them's so you can't read it and one of them's so you can't write it. So I can't see that being the issue. The only thing I can think is that this is not up to spec. It's marked as, and you see the prints come straight off. I'll show you in a minute. You can't see that because of the cable. But as I wiped with IPA when I was cleaning around it, some of the prints come off the top, which makes me think it's a fake. So yeah, I think that might be the issue. I've got some more of these coming from another seller, so I can have a try with one of those. But I think the next thing I need to do is remove it. We'll wait for the sockets to arrive, we'll fit a socket, and then we're not, taking the chips off and on, off and on, off and on. But at the same time, as I'll go away and just verify that and see if there's anything's happened to it since it was heated up, because that might be the case. We've heated it. Maybe it's been damaged from being heated. I don't know. Of course, the other concern with something like this is, has this done further damage, or has something else happened to the board? I don't know. Switch it on now with diagram. You can see it starts normally, and then somewhere here this is normal, and then bang. Hang on, I didn't have this time. We had an address error a minute ago. Why don't we have an address error now? That's really weird. I think there's another fault with this board, actually. It may not be that gal. Oh god, this is going to be a nightmare. I am really, really confused. Yeah, that seems to work. I'm going to try with this original ROMs again. Yeah, yellow screen is back. So what I don't understand is diagram was given an address error and then it wasn't given an address error and seemed to be okay. So I'm puzzled, actually. That's when it warms up, it starts to work. I don't know. Anyway, I think that gal's going to have to come back off and we are going to have to socket it. I hope that's not done any further damage. So it's really mysterious, this. After removing that chip, you still get a yellow screen with Kickstart. Now that might be the case. If that chip is not there, you may get a yellow screen. You can see all the memory's alright on this. Let's just do a quick test of fast RAM. I won't let it go all the way through. But you can see it's going up in 32k blocks there. That's all alright. I've tested that before. Let me just power cycle it. You need to power cycle it in order to get back. Now I've tested the CIAs, I've tested everything else on here. Everything seems okay. So, Why are we getting that yellow screen? I'm going to have another look at the pinouts of that gal. It must just be that gal. I'm going to clean up that gal, stick it back in the adapter there, go and read it on the PC, and just see if it verifies still. So finally, some sockets have arrived. I've ordered 2 different lots. Now these ones seem to fit directly over the pad placement entirely. So these ones need to be mounted with hot air. So you can see I've got a little bit of solder on top of every single one of those and some flux. I need to align this up, and we're going to try and go with hot air. I'll go with a lower temperature to start with. I can't really see what I'm doing anyway, so let me align that. Right, that is aligned as it's going to get. So let's have a go at heating this with some hot air. I'm fully expecting it to melt. It might not do. Yeah, I can see the base melting already, look. Yeah, that's melted. The crazy thing is, it's actually on there. Why is this pin stuck out here like this? So I've got it tacked at the top and the bottom there. Now I had to do 2 things to prep this socket. I had to push the base out. Let me show you. I tried hot air. See what's happened to that? It's well melted. And I used a really low temperature. I was around like just over 300 degrees, which is only just barely enough to melt the solder. So unless you use low melting point solder or heat from the bottom, you could do that. I did contemplate, lifting the board up, heating the underside. That would heat all the pads, and then you could, add the solder and stuff, or you could have solder paste to do it that way. Anyway, you can see that that's mounted now with those 2 pins. I've pushed it down as well, because the other thing I had to do to prep it is cut the pins. I'll show you, well, you can't really see on that one, I'll show you a new one in a minute. The pins are the exact size of the pads. So what I mean by that is when you put the socket on there, you cannot see the pads at all. You've got to mount it with hot air. So all I did is just bend the pins out just a little bit on the underneath and trim the very tips off on all 4 sides, and then fold it back down. But then it's important, obviously, when you press it down, you can see that that's totally flat. As I reflowed these 2 points here, I pressed really hard to make sure it is super flat. And I've inspected with magnification, and the pins all totally aligned up there. So I'll see if I can show you one. I know I've shown this recently when I did the A3660 PCB build. Hang on, which one can I do here? I'll try and do one of the ones, I'll tell you what, I'll do one of the ones up here, you might be able to see a bit better. You've got to be careful not to touch the actual socket. So we'll do this corner pin if I can. I'll just get ready with the pin in the pad, introduce the solder. Let's try that again. Yeah, that is on there. Trust me, you can't see it from there, but that corner pin is now anchored. So anyway, I'll use magnification, just go around, do the others, and then we'll clean up, get the chip in and test it. So there we go, soldered. I've touched the connections up there with the Antex as well, just to make sure they're nice and clean, and they are. Just having a bit of a clean around that. We'll just get the toothbrush onto it as well, I think. Anyway, that's not too bad. Let's get the chip in. So these are the second batch that I got, some ST parts. Can you see that? It's totally different, but it's totally pin compatible, and I programmed it okay. It didn't give me any errors. It probably needs the base sticking back under there, but anyway, that is in place. Let's just wipe over the plastic there, because the plastic looks a little bit fluxy. Yeah, the package there looks genuine to me. This does look like a genuine ST part. So let's go give that a try. So, a bit of an unexpected turn here. The yellow screen is an additional fault. There's something else. Now, it could be from something I cleaned up or reflowed. You know, I soldered some things around here. Something somewhere is giving the yellow screen. This could take me a while to try and get to the bottom of this. But you can see on the IDE, it's actually working. So this is using the first gal that I programmed that I thought was perhaps a fake, but it is actually working. As you can see, you've got the compact flash card details here. It says there .35 CF card, that's correct. Version 2, block size, and it did it on try 1. That was not happening before. So the IDE problem is resolved. I'm wondering if something's gone wrong with Kickstart or something. That's a possibility. It's giving a yellow screen. Maybe there's something wrong with Kickstart. I'm going to try a different set of ROMs on this, I think. Oh my god, that's what it was. This Kickstart's borked. I don't understand how that could have possibly happened. So these original ROMs were took out and put into an ESD pad. Oh, it's got an 060 build on here at the moment, I think. That's probably not going to boot with this card. Might need to fit my other card on here, but you can see that is starting to boot. Oh, it's the RAM as well. There's not enough RAM. Let me stick some more sims in this. Just wait, see if that starts to boot again. Yeah, look, it's booting. So let's do that. Let's fit these sims. If I can get a desktop up, I will be very, very pleased. But that yellow screen has been seriously stressing me out. They can work alright for a period of time and then this mysteriously stop working, but... Oh, hang on, I've got a yellow screen again. Yeah, that's not a good sign, so whatever it is, it's intermittent, it's not the ROMs, is it? Yeah, yellow screen now, look. Oh. You can see I've tested the chip man there, no problems at all, 2 meg okay. Now, if I remove the 2 meg chip RAM and test without it with a normal BIOS, you'd expect a green screen. That isn't happening. I'm getting a black screen, which would kind of point towards Bridget. But you can see we're testing with the chip RAM in there with Diagram, and everything tests out okay, which is really, really weird. Now it could be the versions of ROMs I'm using here that, in regards to the chip RAM. I was testing there with 3.9, so maybe 3.9 behaves different, so I might have to go and get my 3.1 out, I think. Nevertheless, it is very strange. I think it's pointing towards problems with Zorro now. I think we've got an intermittent issue with Zorro, because you saw it booting a minute ago and then we got a yellow screen, and I've had a yellow screen ever since. I think something's temperature related or something around here. I just can't work out what on earth it is. Now, since the IDE was working and we got I got loads of those 245s for there, I've removed them, as you can see, to rule them out. It's exactly the same. The next thing I'm contemplating doing is removing the 245s from here, which I think buffer the data bus to Zorro. Because remember, we got that 12 volt burnt out trace, didn't we? Something major happened to a Zorro card at some point in the past. I don't know what. So maybe that is related to the issue. But whatever this yellow screen thing is, it is intermittent. You see, it goes like red after it's done like a pulsing sequence. This is it coincides with it, yellow screening. And I've got a low there, which is weird. That's like one pin on that side there's low. And if we look at the one down here, you'll see it's low. Hang on, not just another one pin, that one's low. That one stays low. Low. That one's high. That one's high. I think we get to the select pin or something to PA output enable. Let's just check that one. Yeah, I'm just going to go look at the pin out of this because I can't remember where the output enable pin and stuff is there. I'm just going to go check that. Right, I'm going to pull off these Zorro 245s because I need to rule them out. They're crusty as anything. We reflowed them earlier. It's no coincidence that it's now intermittent, you know. This is the sort of thing that can happen when you reflow things and clean with vinegar in various places. Before you know it, intermittent problems have started. You know, it seriously puts me off looking at a 4000 again, this, because when they've had corrosion, it's never just one thing, is it? It's like you start to uncover other things. We've had problems on this with the IDE, with the real-time clock, with the 12-volt rail, which meant there was no audio. Some bad solder points all over the blown place. Lots of things have had to reflow. But these look like they've been off or something. Someone's done something to them in the past. The solder points were absolutely terrible. And they don't look much better now after having been reflowed. So let's just get these chips off. I've got spare ones. Worst case is we just put 2 brand new chips on. If our yellow screen goes away after this, we know that this is the fault. If it doesn't, I'm seriously questioning what on earth's going on. Because everything passes in diagram. I'm not sure if I've made that clear. Like all the CIA tests, the memory test, fast RAM, chip RAM, IRQs, real-time clock, graphics. And I talked about this particular yellow screen issue before in relation to 4000s. If you get a yellow screen and all those things pass, it's going to be something Zorro related, because there's nothing else on there that would stop it from booting if all those things are passing. I've not ruled out the real-time clock doing something weird like interfering with the data bus. That could be something I need to do. Consider removing the real-time clock just to rule it out. And of course you can scope things till the cow comes home. I could scope the data bus here and go, oh yeah, well one of the data bus signals looks a bit low. What is it? It could be anything, unless you do a detailed logic analyzer capture to see where all your chip selects are enabled at the point where you get problems with a data bus connection. You're in the dark. So it can make faults like this very difficult to diagnose. It's going to be almost that temperature, that, because we're right next to it and there's flux already under and around it. I'm not levering here, by the way, I'm just gently pushing like that, and then when it reaches temperature it will come off. There we go. So is that going to solve it? I don't think so. I think it's going to be something pretty random. Might be similar to the problem I had before with my yellow screen on that other board, whereas the problem with the XOR down here or something, I think it was. But I've looked at it, it looks alright in terms of logic probe. Anyway, we'll just let that cool down and we'll go and test it again. Well, I'm more positive than I was, because now, watch, we get a green screen with no RAM. That is looking a hell of a lot more promising. So I think it's those 245s. It's incredible the number of issues with this board. I'm amazed this board ever worked for Ravi. Seriously. I mean, it was intermittent, so he must have had no end of trouble with this board. I know the RAM obviously drove him to despair, because this is why he took it to Neil at RMC, Retro Man Cave, to replace the SIM sockets. But ultimately, that didn't seem to work. He still had RAM problems. But then, following that, obviously this IDE problem, burnt out trace. I honestly don't know what the sequence of events are here that's led up to this. But it's no coincidence that when you get a problem with the 12-volt rail there, massive spike in the power supply chain there, anything connected to Zorro, you're going to have problems with transceivers and things. That's what's happened here. I think these transceivers have become glitchy. But we're getting a green screen. That is really good news. Right, let's get the chip RAM in and see if we get beyond the yellow screen. I'm guessing we will now, hopefully. Let's try that. Ah, seriously driving me to despair, this. I think those chips are a problem, but why have we now got a yellow screen? I'm pretty sure we should be able to get beyond that without those chips in place, so there is still something else going on here. Oh, I am seriously confused. I have spent so long faffing with this. I'm not sure if I've been chasing a particle of plastic, actually. Now, I changed the gal there a number of times at the start when it wasn't working. Can you see that little piece of plastic on my finger? It's a piece of the socket. I think that got wedged between one of the pins and was making the pin an intermittent connection. Now you could argue, so I've wasted time by taking these chips off, but I got new ones. The chips here were awful, so we'll put some new ones on, clean the pads up and they'll look good as new. That chip's not too bad. and we needed new buffer chips for the back anyway, because the ones I was testing with were ones that I knew they worked, but they were off an old board. I'd rather put brand new ones on. But the amazing thing is, after noticing that bit of plastic, you know, as I just changed the chip again for another chip, it's working, I think. I haven't had a yellow screen once. So, is that what it is, or is it still intermittent? I don't like faults like this, actually, because you can think you've fixed it and you actually haven't. So yeah, anyway, I'm pleased. Nothing really lost here. We've not done any crazy work removing all sorts of additional things. We've just really removed what I needed to replace anyway. So this, in theory, that's the first one I programmed up that I thought was a fake. And I think it's just been relabeled. I think that's what's happened to it. I'll just carefully pull that out. I think the other thing I will do is when I fit these chips here in a minute, I'm going to reflow those connections again just to make sure, but the connections are alright. But we'll reflow again, I'll inspect it, we'll clean it out again. So let's just try the, this is the third one I got from a different manufacturer, it's Atmel. So this is an Atmel chip. Yeah, that works as well, which is great, that's great news. Well, does it work? Yes it does, yeah. So I've got quite a few spares here now for these particular chips. I mean, like 20 of them or something, it's going to be ridiculous. I'm never going to get short, that's for sure. So let's take that out, and I'll put the second one I got in, which is the ST part. So this previously, let's say, wasn't really working for me. So let's try the ST. Wow, the ST part's working as well. Fantastic. So yeah, I don't really know what to make of it. Is it that bit of plastic? It must have been. Can't have been anything else. Can't have been anything else. I don't know what else it could have been. Unless it's just going to suddenly start yellow screening again at some point. I probably stressed Ravi out by dropping him a message to say, I've got some good news and some bad news. The good news is the IDE works, the bad news is now yellow screening. Yeah, that's working. And thinking about it, that makes total sense with the whole yellow screen, green screen, black screen thing. That when this was removed, I wasn't getting a green screen. DSAC 1 comes here, actually. I think. I could be wrong. I think it does. We'll have a look at that in a minute on the schematics. But that might explain it. One of the connections on that gal there were intermittent. It's totally in the realms of possibility that this is not generating the DSAC1 signal, which means the chip RAM timing is off, which means you don't get a green screen, you get a black screen or a yellow screen. So yeah, I think I've been chasing my tail again. It's another facepalm moment. But these are the sorts of problems you can have when you do repairs. It doesn't matter how professional you are, I'm not, but no matter how professional you are, these are the sorts of things you can run into. So, place your bets. Do you think the yellow screen's going to be back after I've done this work? Because that's exactly what I am expecting. It's the sort of stressful thing you get where you think you've worked it out and you go, right, let's just fit all these things back on now, and then the yellow screen comes back. But anyway, we're not fitting the same chips over, we're fitting new ones, so these are ruled out no matter what. I think it's a good idea to swap the Zorro ones out anyway, not just because of the bad what's the word, corrosion damage. The soldering was awful, but when you've had a data bus problem as we had on one of these here, and with that there from the IDE the wrong way around, other things on the data bus can die at the same time, and bus transceivers are usually the first in line. You tend to find that the custom chips and things tend to be a little bit more forgiving, and if anything it's because they're going through bus transceivers and are protected. That's one of the benefits of buffers, you know, these transceivers, that they protect things on one side or the other of the bus. But things connected up to the same bus that where the fault occurred can also expire. Anyway, let's just get this off. Right, I just need to clean up, so I'm just going to carefully get that gal out again and clean the whole lot around there and inspect the socket just to make sure it's okay. So I'm using the Heiko just to reflow that. It looks green as anything, that point there. God, Ben, I can't get onto it. Why is that not flowing? Let me just remove the solder there and add some fresh. You know, things like this in the nearby vicinity, it makes sense to clean them up while we're here. Yeah, it's a pretty beefy pad that, I can feel it absorbing the heat there. Anyway, that should do the job. So I'm going to clean the majority of the flux off here with cotton buds first. If you just go straight in with the toothbrush, all you do is you brush all this around the place. Yes, it's dissolved into the IPA, but it just makes it much harder to clean up. You're better off trying to clean the majority of the flux off with cotton buds first. So there you go, hopefully you'll agree, that looks pretty darn clean actually. So I'm going to go test it at that stage. We'll come back and do the Zorro stuff afterwards. I'd just like to see if it's booting from the hard disk, maybe even leave it just running a demo or a game or something for a period of time. So amazingly it is actually working. You can see it flashed away there, look. I'm going to swap the Kickstart ROM over for mine for 3.9 because 3.1.4 is a pain. It seriously is. They've removed some stuff from the ROM which you need to have on disk. I'll show you what I mean. Yeah, you can see there as it boots, it says please insert a volume containing libs/icon.library. That's because this card has been set up with probably 3.1 or something in the past, and normally that's built into the ROM. So I don't like it. I don't like 3.1.4. I prefer 3.9. So just following up from the RAM issue in the previous video, we removed that F245, and do you remember one of the pads came away with it? And I was speculating that that was probably the data bit that was the one at fault. It was the first bit on the lower byte of the lower word. And that corresponds with these four chips here on the schematic. It was this top chip here, I think. And the first pin there, the first data bit, goes to pin 2 on the RD data bus side. So that's the Amiga side, if you like, before the the memory connects to this side here. And looking at the pin out of a 74 LS245, you could look up any of the variants of the 245, F245, HC245, the pinout is the same. And just searching Google, you'll find the pinouts very easily. And you can see pin number 2 there is A1. So yeah, ignore the A's and B's. All it means is you've got an A side and a B side, and data can pass from A to B or B to A. And it's that the direction is controlled by the direction pin, and when the actual output is enabled on either side is controlled there by the output enable pin. But anyway, the pin we were looking at is pin 2, and there is the first bit on that side, and that just happens to coincide with the first data bit that was erroring there in Diagrom. So yeah, it was that pad actually. It's not like we lost the pad because I forced it off. The pad had become detached from the trace. That was the issue. So there we go, all cleaned up the pads. Got 2 brand new chips here. Just need to get these into position and solder them on. That should do it, I think. Let's go and test the Zorro now. So you can see I've got Booty McBooterson there, the A2091, precariously balanced on a disc box, plastic, and obviously connected to the Zorro slot there. And the good news is it's booted. That's fantastic. So let me just connect the mouse up. Let's just see if it's detected the additional 2 meg. In theory, we should have 18 meg of fast RAM there, I think. Yeah, there we go. 18 meg, fantastic. So I'm very pleased with that. I'm going to launch TimeGal and well, give it the TimeGal test. Just leave this going. One of the things I like about this demo, well, it's a game rather than demo, but leaving it running in demo mode, is it hammers the SCSI. It just keeps flickering away there as it goes through the demo because there's so much FMV there. Just connect up the audio because that's not plugged in just now. Yeah, there we go. So I'll leave that on for about an hour, I think, just to test it. So this is about an hour later. Everything is still running fine. Switch that off and boot it again. Yeah, no yellow or black screens. It sits the black screen as it is doing now, the dark sort of one, for a good 20 or so seconds because it's looking for the IDE. But then we should see a flash on here. I'm going to take the board back over to the mat now and finish cleaning up the odd things that need doing on this board, and then give it its final test really, and it'll go back to Ravi once I've tested it thoroughly. So on to largely cosmetic things. I'll get some flux and reflow those in a minute. But you can see, so there's some flux on here, just using desolder braid with a little bit of solder on it, and just tinning over these because they were looking a bit pink. And the reason they're looking a bit pink is obviously because they've been cleaned, and the reason they've been cleaned is because they got corroded. Sorry, that was a bit of a story, wasn't it? Anyway, that is a lot better. So we cleaned those resistors previously, but the solder points just look terrible. So I just added a little bit of flux there, and I'm just going to literally reflow these. You can see that it took some time for the heat because the solder was blooming awful. So I've reflowed a lot of components here. You can see the 2 op amps have been reflowed, the 2 transistors there, these 3 caps here were looking crusty, and I've reflowed various things around here. You know, we did the ground connection there, did oil around here. You can see those have been reflowed. Some of the smaller components up there, the little resistor, the 2 transistors around here, I reflowed the legs on that cap. Down here, the pad there, and that AC. But one thing I just noticed on inspection, look at this. Can you see that diode there? It's pretty much short into that other diode. Now there's nothing under there that I've been heating with hot air. I've not used hot air around here at all. Like nowhere near here. So whoever worked on this in the past perhaps has allowed that diode to roll over that way. Anyway, I'm going to use hot air just to correct that and move it back over there. I'm going to look at the PCB layout actually in a minute, the schematics, and on PCB Explorer, just because I'm curious what that diode does, because it is literally shorting. The contacts are so close that could cause a short there. I wonder if it's on the 12 volt rail. You can see that moved pretty easily there. So I'll just kind of hold it there a sec, there we go, and reflow those with a little bit of solder. So I just tested those 2 diodes to make sure they're okay, and they are. I compared them to my board as well, because the one we moved has got a really low resistance across it on diode test, like 0.50, but that's identical to my working board, so I don't think there's anything wrong with it. I don't think it's suffered a fault around there. It's perhaps when this was originally recapped, maybe when someone removed the caps and things from around here, maybe they reflowed around Paula and Alice with a bit of hot air, and that cap seems to just roll. Yeah, looking at the schematics there, I think these are the right ones. There are some more on the board. They are clamping. You can see one side of the the anode of these diodes here is in relation to ground. Then they go to the signal. Each one of these goes to the relevant signal, and then you've got another diode on the other side going up to 5 volts from its anode to cathode. So they're used in pairs there to clamp each of the red, green, and blue signals. So yeah, one of those diodes just happened to be very, very, very close to one of the others. But if those had been touching, there would have been some sort of visible colour problem. Anyway, we'll get the toothbrush onto that next. This ferrite bead here, I can't find a replacement for that. It's not that essential. It is literally just powering, the joystick ports. So, taking the edge off the power to them. But there's nothing really you need to worry about connected to joystick ports that would be an issue there, because a joystick is a joystick. It's just switches. You aren't that fussed if the power rail to the joystick port is not that good, although it could be actually the opposite, actually filtering noise coming in. In any case, it works fine as it is, so I'm going to leave it. It's a small thing. These ferrite beads, I can't find any information on them, like exactly what their characteristics are. They just measure as a short, so it's just literally a bit of wire. It's the ferrous core that's broke off around it. So I did reflow the point on this cap here before because it looked crusty, but you know what, one thing I always do, certainly when I recap, and I did the same thing on the 2 boards from Stephen, as I recapped, I actually tested everything. So what I mean by that is, I'll show you, just switch this on, and can you see that? no voltage. Now the positive here, if I move to its via, you can see there 4.87, so it's a little bit low. We were down to 4.6 volts there a minute ago, and what I've done is got some contact cleaner on the power connector. So just like on a previous video you saw when I was talking about the voltage drop on these power cables here, I got some contact cleaner in there and it's up to about 4.85. Still a little bit low, but that's my crappy power connector, so I'm not concerned about that. However, I am concerned that this cap is not even in circuit. It's never been in circuit. I'm going to go around and check all the others now, because if that's any indication, some of these others might be suffering from the same thing. And it's not a big deal, because you could run that board like this with many or most of those caps off and it would work, but it's all about stability. You start doing something CPU intensive, you know, you've got lots of current spikes and things from graphics stuff going on, or reading from the hard disk. Before you know it, you get a crash. You get a crash because you haven't got the stability that these capacitors provide. Anyway, so what I need to do with that one there is just feed a bit of Kynar through the hole and onto the cap like there. I'll show you when I've done it. Continuity. And you can see me on the capacitor here, and if I touch the capacitor leg there, you can see we've got a join. If I touch the via here, that goes to nothing at all. There's a break somewhere here between the pad and the via. So yeah, so that's ground, so that one should be 5 volts. Strangely enough, it's not. I'm wondering, that might be on a different rail. Let's just have a measure around here. Yeah, that's on the battery circuit here to the chip. So yeah, these are the sorts of things you need to do. Yeah, so testing one of the chips, that one is in circuit. Yeah, that one's in circuit as well. Now these ones over here, mostly on supply rails and things, and I think one of them here, I forget which one it is now, is the audio bias, and I'll measure that in a minute. You just measure across it and you'll see like 2.5 volts, 2.4 roughly, another one's like plus 12, another one's minus 12, and then you get the coupling caps for the audio. But yeah, you can't just take it as read. When someone's, you know, you've swapped these caps out, you can't just assume they're okay. You know, one thing you could do is just check the grounds as well on the ones on the supply rails. See, like that one's joined, so we know the grounds are alright on those. One of these is going to be reversed because it's going to be minus 12 probably. It's that one, I think. Yeah, that's a short. This one might be the plus 12. Yeah. So the point we need to solder onto on the underside, you can see here, it's very dark. I'm going to scratch very carefully in circular motion around that pad there to expose it. I'm going to tin this one up here and block it, I think. And can you see this trace here? Can you see it's dark green? And there's another one here, look, that goes from the wires that go to the memory buffer on the other side, you know, the F245. And the trace here is dark green. So I'm going to just scratch those off, tin those up, tin that up, plug that, scratch this, stick Kynar through it, and feed it onto the trace of that capacitor on the other side. I'm going to reflow that as well. It looks a bit beady there, doesn't it? It's a bit of a big blob. Yeah, so you can see I've scratched the surface. I did use the fiberglass pen as well as the scratchy tool there, just to get it nice and clean with a bit of vinegar. You can see it's going a nice gold, coppery sort of colour. Same with that pad there, and we'll just have a bit of a tin over that. So we'll just add a little bit of flux here. We really don't need very much. Yeah, it doesn't need to be a giant point like it was, just a little bit of solder on the tip. And we'll bring the braid in and just have a little slide there. Right, so I fed it through there, soldered it onto the cap on the other side. We just need to just try and float a little bead of solder on this side. There we go. It really is that simple. And then if we try and trim that off as near as possible to the via, there we go. That should do, so that's joined back up. I can now have a gentle clean around there. Yeah, I think you'll agree that's looking a lot better. I will give it another clean in a sec. So there we go, there's a final look at that area. Everything here is clean. I just reflowed those 2 pins there. You can see they look alright. They look a bit dark when you look down on it like that, but they were super corroded. Anyway, I'm just going to straighten that cap. Yeah, there we go, that's a bit better. So I've been doing the same thing I always do, which is to, work on some stuff, clean some stuff, fix some stuff, and then go test it. Just to make sure it's still working, because when you interfere, as I mentioned before, interfere with some of these wires and things, you may create a problem, and then suddenly, after you've done tons of work to it, it's not working, you're like, oh my god, where do I begin? So it is better to, do little bits. We've done the stuff primarily around here on that cap and stuff, and just a bit cleaning up again. It's up this jumper. You can see it's got a crazy, insane jumper. Look how close those 2 pins are there. If we pull that off, let me just show you. Look how small that is compared to what should be fit on the left-hand side. So yeah, we'll just straighten those pins out somewhat. 1 or 2 of the pins are a bit bent on this, and stick a proper jumper on like that. So just measuring that capacitor, can you see that 4.81? Yeah, it's a bit low. It's the power adapter I'm using, but on other areas of the board we've got a similar sort of voltage, so yeah, no issues. And you can see I'm testing with my 040 here, which is what Ravi will be using until he fits his 060, which he should be doing soon, I think. I just can't get enough of this demo intro thing here on Pinball Illusions. So I think I'm all done here. Let's just let this boot again. You can see it flashed once there, flashed again. Get a delay because it looks for the floppy drive, I think. And it may well be this version of Kickstarter I've got. It waits a bit longer to look for other IDE drives, because there are a few pauses there when you've not got a floppy drive and other drives connected. So that's booted up, and you can see it is the same system. I needed to move the camera there just to show you it is actually working. So I've not had the yellow screen issue at all since I removed that bit of plastic from the PLCC socket. Now the thing that's bothering me about that, I don't really understand how that piece of plastic could have got in there. It just doesn't make any sense. I just don't get it. Maybe I don't know, maybe when I pushed the base out it went up the side of the socket or something into one of the pins, but then when I was soldering I never saw it. This is the weird thing. So this is what's bothered me about this. I've obviously been testing this for 2 days now while I've not had the yellow screen, and everything's been fine, no recurrences of it at all. And just based on other actions I was doing at the time when the yellow screen seemed to disappear, just before that I was probing these wires here. We still have the yellow screen, but then I saw that bit of plastic, removed the bit of plastic, put the gal in, and the yellow screen went away. So anyway, I plugged these wires just because those are the ones that I was probing just prior to that, just in case it was one of those. And I plugged a few more around here, everything around there. I'll give you a close-up in a minute. We'll have a look at the board when I take it back to the mat. But everything's looking super clean and tidy. Voltages are all there on all the caps and things. I measured everything around the audio circuit. All the levels and things look fine there. Changed that jumper. Anyway, let me take you back over to the mat. We'll have a look at the board. So booting from floppy, I've tested the floppy drive, tested the serial port there. We'll do the parallel port. I've got the dongles plugged in to the back at the moment. So yeah, serial and parallel are good, and the floppy drive is good. And the real-time clock has been running for a few days there. You can see the batteries in there. That is the correct time and day. So yeah, everything is working. And the joystick and mouse as well, by the way. So I got the SD wrist strap on again. I've had that on while I've been handling this. So yeah, these ports, they were not aligned, were they? You can still see that. This one is a replacement. It sticks out slightly further, and I think that's why the ones on Cather's machine got damaged, because they protrude just a little bit, like a millimetre. So if anything hits the side of this in transit, the case, that is, the bubble wrap, it's putting massive pressure on this. So anyway, I'll make sure it's well packaged. It came in a decent sized box and an ESD bag, so it'll go back that way. So if you have a look around the audio section now, you can see it's looking a hell of a lot cleaner. I reflowed the caps there, the ceramic ones, and we cleaned up, got rid of all the corrosion and stuff. reflowed the op amps there. I couldn't replace that 4/8 bead, I've not got anything similar, but as I say, it just powers the joystick ports, so it really isn't a big deal. It's the least of this board's worries, I think. I flushed out that cap there. Still looks a little bit green on the inside, but yeah, the trim cap, that is the yellow one. And I obviously cleaned all around there, plugged those wires there. Can you see we've got 4 wires plugged all the way through to the other side, and some of the wires around the 7.4 chip here, well, all the wires around that actually. I think they were mainly like the supply rail and a ground rail, but anyway, they're joined through to the other side properly. That cap there, the solder point doesn't look good on it, you can see, but it is joined with a wire through to the other side. And again, around here we cleaned up these resistors here, and I reflowed those chips there. Yeah, I couldn't do the right side of that right hand chip because obviously the battery is in the way and stuff. There's nothing else under there, so it really wasn't worth taking off. The battery, I've put a brand new battery. The battery that was on there was down to 0 volts. It had gone completely flat. I reflowed this chip here as well, you can see, and then obviously we reflowed any of these super corroded pads, you know, that one and that one, and the one up here was very green, and then after I cleaned it, it was a little bit pink because you could see the copper. You know, we swapped the jumper over here, I think it was, that was wrong as well. And then these 2 chips have been replaced because the ones that were on there were really crusty. I wouldn't really like to leave them. And then over here we reflowed that diode because it was green on this side here. 2 new HCT 245s, socket, and a new gal. You can see the one I've left on there is the ST part. It's an equivalent, and I've been testing it pretty thoroughly. No issues at all. Everything else around here I think looks okay. I did clean those 3 chips there because those were a little bit greeny. Not a lot, just like a bit of you know, the corrosion got to the surface. Everything else I think on this board is looking okay. Other things before I forget, I got some contact cleaner into here, 2 passes actually, the Oxit first of all, and then some WD-40 contact cleaner just into there. I actually sprayed it into the connector and plugged the connector in and out, in and out, in and out. And of course I relocated one of those diodes. I checked what those are. Those are the clamping diodes for the red, green and blue signals actually, so I can't imagine that would have been causing a problem. Before I forget, we've obviously got that fixed wire there on the underneath for the 12 volt rail. Could it have been done tidier? I don't know, I don't think so, because the rail had disintegrated. You could have started to try and epoxy the bits together and join them up. Very dangerous, as I say, because those bits come loose or something, you've got 12 volts flying around. It's better to have it isolated with a sleeving like that, I think. That's my personal view anyway. And we also cleaned up the points on the joystick ports here as well, and straightened one of them so it was, you know, because it was dead crooked. Now they're not too bad. And then obviously wires and things blocked here, you know, green bits cleaned up and resoldered, and then I just tidied up the sims there because there were just a few blobs there that RMC left on there. They were not too bad, to be honest. It's just me being a bit pedantic. So yeah, overall I'm very happy with that. Just worrying me about the yellow screen. I've asked Ravi if he wants me to, well, what he wants me to do. Do you want me to test it a bit longer? I'm quite happy to send it back as it is, but the yellow screen is worrying me a little bit. I haven't seen it since it disappeared. I can't really explain it really. So the other thing I've done here, and you are not going to be able to see it, it's too small. My camera cannot even film it. Let me just see if I can point. There is, it's a bit scuffy here because I used the fiberglass pen just initially. Yeah, there's a trace here that joins the wire, you know, comes from one of the connections here to the wire, and I very carefully cut it. I tried to use the fiberglass pen start just to get the surface off the wire so that I can actually measure connectivity. It turns out there's an easier way of doing it actually. If I measure on continuity, I think before you cut that trace, these 2 components here, CS5 and CS3 I think they are, the bottoms here will be joined, and you can see they're not joined at all. Those 2 are joined. That worries me a little bit. Yeah, so those sides are joined, but I think it's the bottom sides that get joined. Anyway, let's just test over here to the wire. I can't even find it. Yeah, that's the wire. That one goes to the wire. That one doesn't. So I think that should be okay. In theory, what you can do is measure across here, and we should have 1.8 volts on one and 3.3 on the other. So I think I'll do that. I think I'll connect up the little PCB back on here, connect it up to the Amiga, the Zorro slot there, and measure these voltages. Now, that, thinking about it, might be hard. And maybe not. This board, this side here, might be top side up, thinking about it, because the connectors are on the other side here, which are going to be out on the back. So yeah, I might be able to measure these actually in situ. So going into the expansion board diagnostics there, you can see the manufacturer ID of that card and product ID, and it says states there working. I can't test it fully because I haven't got obviously the drivers and stuff for this, and I honestly can't be bothered messing around setting it all up. Right, I've pointed you down a little bit and out a little bit. Let's just switch it on again so you can see these various LEDs here. I'm going to put it in volts DC mode, and very carefully see if I can just reach across here, not short anything, and measure across these components here. So you can see there 3.3 volts, and we'll do that one carefully. And you can see that one there is 1.8 volts. So the voltages are separated. Hopefully you saw that. Before you do that mod, those two would be joined together, so I'm glad about that, because that was a nightmare cutting that trace. It seriously was. It's a nice piece of hardware, this. I think Modern Vintage Gamer did a video on this. It's the ZZ9000, very nice. It's very nice indeed, very expensive as well. It's about €350 or something, I think. It's not just an RTG graphics card. You've got an micro SD adapter there. I'm not sure whether you can mount that. You may be able to, or that might be for firmware. I've got no idea. But you've got USB, an RJ45 LAN, and HDMI. So yeah, very nice. So as I say, I didn't connect this bit up. I know this is kind of optional. So we've not tested it properly, and as I say, I've not got the drivers. What we do know is measuring across those two caps there, we have two independent supply rails. 1.8 volts at the top, 3.3 volts at the bottom. Yeah, look at that. Amazing. In with the board there was this magazine as well from Ravi, so yeah, very cool. I think there's some tactics going on here. Let me just show you something. I was opening the page here and I was like, oh look, that's Ravi, what a surprise. I'm sure he's trying to show off. He's near again, look. Maybe he co-edits this, I honestly don't know. I think perhaps he does. I think these are the editors or something, I'm not sure, could be wrong. It's the Ravi magazine. I'll have to read through this, it looks pretty good. It's a bit thin, but magazines are these days. You know, if you look how thick they are, and then look how much it is. How much is this out of interest? Yeah, €4.99, €5.50. Good God, magazines have got expensive. So it had 3 solid days of testing with no yellow screens at all. Although the yellow screen, as I said a few times here, has just been bothering me. I don't really know 100% what caused it. The piece of plastic in that socket back there, I'm not so sure, because if you actually remove that chip, you don't get a yellow screen. So that's a little bit weird. It could have been that because it was affecting the timing of one of the signals there, that it was given a yellow screen. But yeah, I am not 100% sure. Anyway, I can't do any more. I could just literally just keep testing this for the next month, I guess. You know, I don't know, but Ravi wants me to send it back, so if he has a problem with it, he can always send it back to me. It's obviously very expensive to ship because of the insurance, but anyway, I think it's okay. I have got no reason to believe there's still a problem, but you never know. Intermittent problems can be a nightmare. There you go, booting from hard disk. And as expected, it's going on about the icon library there, so as I mentioned before, you'll get that with 3.1.4 and a workbench install from 3.1, for example. Anyway, it's been nice to get this up and running. It's taken an incredible amount of time. I've spent about 2.5, almost 3 full days working on this. You know, we've had lots of little bits, as I kind of summarised as I showed you the board there towards the back end of this video. I've cleaned it up fairly well. There's very little on here that you would look at and go, oh, that needs cleaning, or that needs resoldering or whatever. I can't really see anything that really needs any more attention other than that ferrite bead, but it's a non-issue really, that ferrite bead. And because of the problem we had with the GAL right at the start, I ended up with 4 different manufactured chips, and then I couldn't get the sockets, and I waited ages and ages and ages, so I ordered some more sockets from another seller in the UK. I ended up spending like £50 on parts. Now I can't charge that to Ravi. I think in summary the parts of flux and IPA and cotton buds and braid and everything has come to about £18 or £19. It's not a lot. That includes the GAL and the sockets and the 2 chips and all the consumable parts. So yeah, none of my time has been charged for you. If he wants to give me a donation, I've asked him to wait until he's tested it, maybe for a month or something, until he's happy with it. And then yeah, I'm quite happy for him to donate a small amount if he wants to cover some of that stuff. But I mean, if you need a GAL or a socket, let me know. I've got absolutely tons of the bleeding things, like about 20 of them. And they all do work. I tested, this is a crazy thing, I ordered different ones thinking, oh, is there going to be some fakes here? I'm not really sure what's going to work and what isn't. So I ended up with like 3 different manufacturers, yeah, across 4 different suppliers, and they all seem to work actually. But I'll perhaps show you in another video. You can see that they definitely have been badged. Not the one that's on there now, the ST part that's on there now, it's a genuine label, and that's why I've left that one on there, and that's the one I've tested mostly. But all of the others work fine. So just switching that off, to summarise, so what's caused the faults? As I mentioned before, compact flash card, you know, IDE card in the wrong way, like that. The other possibility is it was misaligned by a row there, you know, so if you've not got it on both rows, you just got it on the top one or the bottom one, you're going to short things out. And my final thoughts on the yellow screen, I don't think it was related to that socket there and that little piece of plastic. I think that was just yet another coincidence. I think it was the vias next to the F245, the one where we replaced in part 1, related to the RAM faults, because some of those vias around there, I think one of them is the BRW signal, and that comes to Bridget. Now, if you remember, when we were having that particular problem, at one point I showed you got a black screen instead of a green screen when you've got no RAM in there. That's an important test to do on one of these boards. If you get problems, you know, take all the RAM out and power it up with Kickstart, you should get a green screen. If you don't get a green screen, it shows there's either something really wrong where it's not booting from ROM at all, or there's something wrong when it comes to the addressing of chip RAM, because you know, Bridget, it's kind of like I've mentioned this before, it's like a glorified Neo buff. You've got lots of buffering goes on in there to buffer between the different sources of data wanting to come in and out of the CPU. So, you know, but primarily it's the main gate to the chip RAM. So if you've got a problem with this, you'll either get a green screen all the time or a black screen or something, you know, something weird. But because those vias were affected around there, that's why I plugged the, I think, 5 or 6 vias around that 245. But one of them was this BRW. That's the right, it's the read write, but I don't know what the B stands for. Anyway, in any case, that comes in here, it's this direction pin. That would mean data's going the wrong blooming way or something. So that's the sort of thing that if one of these signals here is missing, yeah, you could start to get a black screen or a yellow screen, etc. Or you could be lacking the green screen. But ultimately the other issues on this board were all caused by the original battery leakage. So yeah, and obviously this has been worked on before, as I mentioned right at the very start. It had the new SIM sockets here from RMC. I think what's perhaps happened with this is what I pointed out in Cather's video, which is, you know, when this is in this position here, let's just see if I can demonstrate. In the Amiga, these cables here are sort of sat around this area in the power supply bay, and they can very easily short onto these pins here. You know, all you need is to short ground to somewhere here where one of the supply rails are, like the 12 volts for example, and you're going to short out the trace completely and burn it up. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see Coffee and Patreon links down below. I'll catch you in the next video.